Question 50 asks us to find the value of r when we are given some matrices. So I've written here a simplified version. I'll show you what the question wants us to know. So the question includes this, but instead of just saying that it's equal to this, it says that it's also equal to and it says all three of these are equal. It's much simpler to work with multiplying two matrices than it is multiplying three matrices, and since they're all equal, I just worked with the top one and set it equal to just one simple matrix here. And sorry, I have very good. Multiplying matrices can seem confusing at first, but there's a process that you want to follow. Sometimes it'll be referred to as dot multiplication. Essentially, you start with the first row of the first matrix and the first column of your second matrix. And you multiply and add according to the positions of the numbers. So for instance, the calculations for this would be 2p plus -1 times r, which is just negative r. And then it's going to be equal to 1. Then we do it again for the next column. 2q plus -x. And this one is going to be equal to 0. Then we do it for the bottom column. 2p plus 3r is equal to 0. And then last but not least, 2q plus 3s is equal to 1. So here we have all of these calculations. So really all we're looking for is r. And so we're going to look for the equations here that have r in them. That's these two. So we can eliminate the other two. They're not important to us right now. So now we solve for r, and we're going to do this by using a system of equations. So we have our system set up, and now we can just multiply one of these by a scalar to cancel out the values of p so that we're left with r, and we can solve for r. So we're going to multiply this top one by the scalar of -1. So I'm going to rewrite it down here, -2p. This is technically minus r, and so times -1 is plus r is equal to -1. These two cancel. We're technically having two equations. This is 4r is equal to -1. R is equal to -1/4.